So for me to use this equation here, we need to figure out what is my dq, what is my r squared, and what is my r hat. Once I have those three quantities, I should be able to do my integral. Right? Now, in this example, because I'm talking about a line, my dq is very simple to write, so it's just, now, so whenever I give you this problem, we're going to assume that, so this rod has a total charge of, so it has a total charge of Q, right? So it means that this will always be given in the problem. So we have the total amount of charge Q divided by the length L is always given in the problem. So it means that I can write my dq as lambda x. So that's the first part. Now the second part is to get the distance r squared. Now what distance are we talking about here? The distance that we're talking about here is this distance. So I need to create, so let's make a small element here from calculus. So let's say that this is the x. If this is the x, then it means that the distance from here to here is x. Does everyone agree with that? Now, what is the distance r? The distance r is the distance from the source. So in this case, my source is my dx, right? So what is the distance from my dx to the point P? It's x squared plus a squared. So it's this distance right here. So this is my r. So this is equal to x squared. So I want to show you step by step how to set up everything, right? Now, what is my r hat? So my r hat vector. Now, to get my r hat vector, let's put an angle here. I'm going to call this angle theta. So if this angle is theta, then let's say that. So it means that now, so that is the same angle, right? That theta. It means that my r hat vector is pointing in the northwest. So northwest means that the x component is negative, the y component is positive. So you can see that my r hat vector is equals to negative. So in this case, it's negative sine. Okay, so we have a question from a student online asking about the distance r squared. So to get the distance r squared, again, if you look at this, so do you see that there's a right triangle here, right? So there's 90 degrees here. So basically, so let me draw just that section. So this is my dx here, this is my x, this is my a. So there's a 90 degrees here, and this is my r. So it means that by Pythagorean theorem, r squared is equals to x squared plus a squared. So that's how we calculated this r squared value. So it's just from that triangle right there. Okay. So let me remove this triangle here. Okay, Now, does everyone agree with this unit vector here? Because I think this is the key. So if your unit vector is wrong, your integral is going to be wrong. Yeah, go ahead.
What if you took a dx from the other side? Wouldn't you have to change the sign? Like, do you make two of these? Or?
That's a very, very good question. So now, okay, so that's correct. There is two, and I'm going to talk about this later on. So when I do my integral, do I do my integral from 0 to L over 2 just to cover one part? Or should I do my integral, for example, from negative L over 2 to L over 2? Right. So you're going to see that, you're going to notice that I can do my integral from negative L over 2 to L over 2. Or I can do it from 0 to L over 2, but then I must multiply by 2 to cover everything. So because this point is my reference point here, so it means that I can say that this is plus L over 2, and this is negative L over 2. But the key point is this unit vector here, because if this unit vector is wrong, everything is going to be wrong. Yeah, go ahead.
I'm still a little bit confused on how you can say that is the unit vector, but like dx is like can be anywhere in between.
All right, so I think it depends. So now when I create my unit vector, I can use any of those two angles. So if I use the angle at the bottom, then this unit vector is going to be negative . You're always going to be very careful how you use your sines and cosines in terms of x and y components. Right. Now, do you see that because theta plus phi, because theta plus phi is equal to 90 degrees, you can see that the cosine of phi is the same as the sine of theta. So it takes a little bit of trigonometry, but you need to know exactly how to set up your unit vector. So if you wish, you can use this angle here. If you wish, you can use this angle. Any of those is going to give you exactly the same result if your trigonometry is correct. So you need to decide what angle you want to use when you set up your unit vector. Right? So I chose to use this, but using this will give me exactly the same result. All right, now, so let me go ahead and, so keep this equation in mind. So keep this in mind, keep this equation in mind as well, keep this r squared in mind as well. And then, because I'm using this angle here, this is our unit vector, so it's negative sine and cosine. Now, just because of time, let me just go ahead here. So I'll write down everything that we know so far. So my electric field is KE . So this is what we have so far. Because my dq now this lambda is a constant. So I can put it out of the integral. So I can write this as KE. Lambda, the integral over dx divided by a squared Now, do you see that I've substituted my r squared with a squared plus x squared? And then I'm going to go ahead and substitute my unit vector here, which is r hat. So my unit vector is negative. All right. Then let me go back and draw just part of this triangle here. So this was x. And this is a. So let's calculate sine of theta. So what is sine of theta? So sine of theta is equals to, so from this triangle, what is sine of theta?
X over R.
X over r. So it's x a squared. Does that make sense? Because r squared was a squared plus x squared. Then r is the square root of a squared plus x squared. Then let's get our cosine. What is cosine of theta?
R over, I'm sorry, A over R.
It's a over r, so it's a divided by a squared. Now, why is it important to calculate sine and cosine? Because I'm doing an integral over the x, but the sine and the cosine is changing also with x, right? Those are functions of x. So that's why I need to include everything in my integral. So finally, let's take this final expression here. And see that this is equals to ke lambda. So this is the integral, negative L over 2 to L over 2 x. So x dx divided by a squared. So this term, everything here is equals to. So remember that this negative here just comes from that negative sign. Now, does everyone see where the a squared plus x squared to the power 3 over 2 comes from?
Where did 3 over 2 come from?
The 3 over 2 comes from because sine is x over a squared plus x squared to the power of half. So let me write it on the board here. So you have the x over, then we multiply this by sine. Sine is negative x over cosine is a. This multiplied by this is a squared plus x squared to the power 1 times a squared plus x squared to the power half. 1 plus half is 3 over 2, right? And then the next term, so this is the I component. So all of this is I. And then my j component is plus, so plus ke. Now, I can pull out this a is a constant, so ke lambda a, the integral from negative L over 2. This will just be dx. All right. Now, I think we ran out of time, but I want you guys to keep track of this. So when we come back in the next class, I'll give you a table of integrals, right? Then using table of integrals, we need to look up those two integrals. And then once we get those integrals, that should help us get our final value.